Okay, so this section is obviously on Assessment Task 1, the literature assignment. Basically, the literature assignment is all about asking you to start getting to think about coordination compounds and how they actually fit together, how you name them, all that kind of stuff. Now, for you to do this assignment, basically you have to know some fundamental ideas about coordination compounds. And that's what I'll be delivering in this lecture. So with that, and with a little bit of practice and an example that I've given you, you shouldn't have too much trouble with this lit assignment. That's basically just a screenshot there, broad overview of what's actually happening in this assignment. It's worth 10%. It's due Friday, week 4, 11:59 p.m. After that, penalties may apply. The task is basically you just find one paper there that deals with preparing a transition metal complex, and you've got to answer a few questions about it. Those questions are actually here in this downloadable document, which we're going to look at in just a moment. I've included this paper here just so I've given you an example of what's going on as well and what's expected of you, so that really it should be pretty clear and straightforward. So what I'm going to do now is go over to Blackboard, drag it over, and we're going to go into the assessment section for the course, and we're going to go to the literature assignment, and there's the real deal. That's what you would see in Blackboard there. And that's more or less what you were seeing just before in that screenshot on the PowerPoint slide. So really the pointy end of this is this document here, Assessment Task 1 Lit Assignment .doc. Now, excuse me, once you've done all of that, there's actually some instructions there as well on how to submit your assignment, and there's also information about how we're going to mark it, and that's pretty clear as well. It says here, click on the folder heading and carefully read the rubric. So if you click there, that should take you to the rubric, and you can view the rubric, and there's the rubric there, and that's how we're going to mark it. Okay, so let's just go back here for a minute. Let's download this document and open it. So this is precisely what you'll see. You'll open this document here, and there's the task again. Now what you're going to do is you're going to find your paper in PubMed. The hypertext link is there for you, so no problems there in finding where you've got to do your search. You enter your search term in there as per the instructions, and you will get a bunch of hits that come up, something like that, for example. Over on the left-hand side, there's a button or some text here that says free full text. That means if you click that, the search results that you get will only give you papers that you can immediately click and look at the full text of those particular papers. So there's no mucking around going on here. Clearly you need to look at the full paper, but you can very quickly do so by using this particular procedure here, which is what it says there. Click on the link for full free text. You pick the paper, and then there's an assignment template below in bold, and that'll show you what to do. And then of course there's, to complete it, you have to submit it. The instructions are there, and they're also in Blackboard on how to submit it. Okay, so the template, here it is here. So what I've done is I've given you not only the template, but I've given you an example of what we're expecting. So the example uses that paper that was in the attachment. Just move that out the way. This paper here, right? So you can see precisely what it is that we're doing here. So what do you need to do? You need to put in your name, your student number, of course. Put in the title of the paper. There's the title of the paper. I've even got an instruction here that says copy and paste exactly, so you know what you're doing. The URL, That's so I can look at it, right? So when you submit it and you make, when you fill your template out, that I can actually look at the paper as well, so that I can double check that what you've written is sensible. So really the first question that you've got to fill out is this one here. All the rest is just basically all the preliminary stuff that we need. And so the question is, why was the work conducted? And all I'm after, as I say here, is a brief explanation. In this case, just one sentence, that's sufficient, right? That this is more an exercise about getting you, trying to get your head around what these coordination complexes look like and how they put together. Okay, now 6 here, it says insert a diagram of the structure. That's so I can have a look at it and then you can mark on it these particular aspects. So the metal ion, and then you also need to indicate where the ligands are and what the oxidation state of the metal ion is and how you figured it out that that was the case. So in this example here, this is the actual complex here. There's the metal ion there. There's 4 ligands. Now you don't exactly know what a ligand is yet, but they're the bits that attach to the metal ion. You will by the end of this whole lecture. So there's 1, 2, 3, 4 ligands here. This ligand here and here, they're both, well, they're the same compound. They're actually neutral compounds. This one here, I can recognize as chloride ion ligands. You won't exactly be able to at the moment, but you will by the end of this lecture. And so since the overall charge on this complex is 0, as indicated by the authors, then the obvious conclusion here is that the metal complex must have, or the metal ion must have an oxidation state of 2+, which balances out each of these 1- charges on these chloride ions, and that's what I've written here. I've drawn circles around here indicating that they're the ligands. Now, when you do your report, you're going to have to bring up your paper as a PDF, take a screenshot of the particular complex, just like I did, and then once you've got that screenshot, you can then annotate it. Now, I just annotated mine in PowerPoint and then copied the lot over into Microsoft Word, which worked fine and pretty easily. Okay, number 7, explain how ligands are involved in bonding. That's going to be one of the big deals in this course is ligand bonding itself, and basically it centers around the idea that we have originally non-bonding pairs of electrons that can get involved in ligand bonding. So in the case of nitrogen, as I've explained here, those electrons is nominally 2 of them. There they are there. And they contribute to this dative coordinate bond. Again, more of that when you go through the rest of the lecture. Chloride ion, similar idea. And then what I've done here, I've just pasted the diagram of the complex in from the paper again, and I've just simply got some circles that I've drawn in PowerPoint, and then I put them on indicating where the electrons are there, so we know what's going on. Okay. How's the complex prepared? Basically, you just have to summarize whatever they've said, right? And you can see here the summary. I'm not expecting a huge amount of detail, just a bit of an idea. And then finally, how do they know it's this, right? They didn't just dream this up. There's got to be some reason. So what kind of methodology was actually used? In this case, it was X-ray crystallography. Okay, that's basically it. You can't really exactly do this assignment yet until you've had a good crack at lecture 2, but I hope that's at least whetted your appetite and explained what it is that's actually required of you as far as this assignment goes. And did I say assignment 2? I meant the literature assignment, task 1. Anyway, all right.